Hello everyone. I've looked over your questions and feedback. Before we begin, I want to clarify a couple of things right away. This is not the standard controller that everyone has long been used to. There are no corrective actions used here, you won't need any scripts, and the mechanism works smoothly even on older versions. I tested it on version 12. If you came here looking for a ready-made solution, it's already available on my Telegram channel. Go ahead and grab it. Next, probably the main question, why was a new controller needed at all? The thing is, the classic controller has two weak points. First, when correcting smart bones mixing, the system doesn't take bone corrections into account. That's because Moho has limitations on action nesting. Second, the blending mechanism itself works in such a way that the third corrective smart bone only activates when the first two have already been triggered halfway, not before. Now let's define what we need. We'll need three actions: vertical, horizontal, and diagonal. Each of them should work independently, and blending occurs in pairs, horizontal with diagonal, diagonal with vertical, and vice versa as well. Let's start with two bones, X and Y, which will change their scale depending on the movement of the controller bone along the X and Y axes, respectively. Next, we'll create two small bones that will move along the X and Y axes. There should be no parent relationship between the bones. Let's move the bones to the center of the coordinates and assign them a color. Here and throughout the lesson, bones that are controlled by the main bones, or as in this case, serve as targets for the main X and Y bones, will be highlighted with colors. The position of the targets is controlled by the controller along the X and Y axis. They need to be shifted slightly, otherwise, when the timeline is not at 0, the X and Y bones will change their angle as if the targets are somewhere to the right. Let's set the maximum inverse kinematic stretch for the bones and assign the previously created targets. Let's check if it works. Next, we'll create a structure that will ensure our actions work correctly. I spent a long time deciding on the form of this structure, but eventually settled on an equilateral triangle. It's important to do this in order to get the correct ratio between the bone scale values and the action's rotation. Next, we need to separate vertical movement from horizontal movement. This can be done, for example, as follows. Two bones, one of which is a child, are oriented opposite each other and change their scale proportionally to the X and Y bones. Thus, when both the X and Y bones have the same scale, the action will not be triggered. Let's set the target for our action and name our action. Some bones in this setup should not be affected by inverse kinematics. Let's copy the setup for the horizontal action and also assign a color to the actions. In the horizontal action setup, the control of the bone scales needs to be swapped. The scale coefficients should remain the same. Next, we'll create a layer with a rectangle, which we'll use as an example to test the functionality of our actions. We create a vector, use the tool to get the coordinates of each point of the rectangle, and create a pin bone. You can also create a main bone. We attach the vector to the bones. Finally, let's create a vertical action. Our actions operate within a 30-degree range, where at 150 degrees, the rectangle should be in its initial position, and at 120 degrees, in its final position. In this way, we've achieved an upward rotation of our rectangle. We do the same for the horizontal action, thus achieving a leftward rotation. Yes, and as you can see, these actions do not mix. In the construction of the diagonal action, we will need the difference between the X and Y bones. You can obtain it, for example, in this way, so this way we get the absolute difference between the X and Y bones. At the same time, the resulting bone should change its scale from 0 to 1. Let's assign a certain color to the bones and specify the required scale control. To make the resulting bone change its scale from 0, go along the timeline and set the scale as low as possible, but not 0. Then copy the scale key and paste it at frame 0. Finally, set the maximum value for the inverse kinematic stretch. Next, let's create bone Z, which stretches freely and follows the controller. We have obtained all the values we need, and now we can proceed to create the diagonal action. The scale control of the bones in the setup is achieved by the difference between the bones and bone Z. Thus, the diagonal action will only work when the difference between the bones is minimal and bone Z has the maximum value. That is, when the controller is positioned along the diagonal, and it will not work when these values match, meaning when we are on either the X or Y axis. Let's check how it works. In this way, we have actions that work only in their respective directions: horizontal, vertical, and diagonal. To be honest, the most important thing in the entire controller setup is the operation of the diagonal action. The most difficult part was making sure that the diagonal action worked only within its designated area. Everything else is not as important. In fact, this became possible thanks to the difference between horizontal and vertical movement. This is the main trick. Let's look at a few situations. When the controller is in the maximum diagonal position, the difference between the X and Y bones is 0, which means the diagonal action is working at its maximum since the Z bone has the largest scale. In another case, when we are on one of the axes, the difference between the X and Y bones will always be equal to the scale of the Z bone, which means the diagonal action will not work. And let's also consider the case when the controller is halfway along the diagonal movement. In this case, the diagonal action, as expected, will have half of its effect, and as you move toward any axis, the effect of the diagonal action will approach 0. I hope this has become clearer. Let's make it so that our controller works in all areas. To do this, we need to use the rotation values of the X and Y bones as follows. We also need to refine the design of the diagonal action a bit. Let's rotate one of the bones so that it is vertical and place a new bone on it, which will rotate the action structure following the target. It needs to be placed on the bone that will rotate following the X bone. The action bone should be cut, pasted, and its target reassigned. Let's finish up our actions. Actually, there's nothing complicated here. Just remember that each value of the smart bone should correspond to a certain state of our object. You can use a small reference chart that shows the relationship between the smart bone angle values and the state of the character, or as in this case, our rectangle. Finally, let's remove the dead zone in the middle. To do this, set the minimum scale for the X, Y, and Z bones and increase the maximum scale for the inverse kinematics. Adjust these values depending on the size of your controller. For example, you can use these values. Let's adjust the scale of the other dependent bones. You need to set the values so that the maximum scale of the bones that depend on the main X, Y, and Z bones remains the same. I mean, just like before this step. The controller is ready. Let me remind you that you can download the controller file from my Telegram channel. I should note that such a controller isn't always necessary. For example, if your movement has a small amplitude, it's better to create a corrective action instead. Don't overcomplicate things. Do it the classic way. And remember, there are no perfect solutions. Everything has its drawbacks. This controller option is no exception. I think we can answer a couple of questions at the end. One of them is it necessary to separate the horizontal and vertical actions? Not at all. A diagonal action can serve as a corrective action. Is it possible to make a square controller? Yes, instead of the Z bone, you'll need to sum the X and Y bones. Subscribe. Maybe someday I'll record a video on how to make such a nice panel using just 3 actions. Goodbye everyone, thank you for watching.